Hello, I'd like to explain a little bit more about rational numbers and irrational numbers. Now, the set of real numbers, which is like in italics double-stroked R, is all real numbers on the number line. But the set of real numbers can be split up into either rational numbers, which are predominantly fractions of integers, and we use double-stroke Q, or irrational numbers, not rational numbers, which cannot be represented like fractions of integers. Now, let's just do that double stroke. Now, I've just mentioned the word integers, and it's useful to know that integers, a special set of numbers that, oh, I've made an error. Let me just backtrack. Sorry about that. Getting carried away with myself. Irrational numbers. Did you spot that? I'm sure you did. Is a capital I. And Z, the set of integer numbers, which are numbers which have no decimal places. They are no parts. So -7, 3, 5, square root of 16, square root of 49, 8/2. You see, that's the number 4. -16/4. That's the number -4. You see, no parts. All right, integers don't have any decimals. So if you take any two of these and you can make a fraction of integers. Oh, let me just get rid of that. 9. Change the color. We can take any two integers, fraction of integers, such as -7 on the numerator, 3 on the denominator. That is rational. Right? So we've got a rational number. Now I want to put up here another number which I didn't include, and that's the number 0. 0 is an integer. 11. Very large integers, 1,540. Very large negative numbers, negative square root of 10,000 happens to be -100. Okay, now, of course, 16 under this square root sign, because 16 is a square number, it works. So that's the number 4. So I'll take square root of 16 and put that on top, and then I'll take 5 and put that underneath. Any two integers. The thing is, we cannot use 0 on the denominator. That's our only rule here. We cannot use 0 on the denominator. So if we can use 0 on the top, you can put 0 on the numerator. That's fine. And square root of 49 on the denominator. It's okay. But you just can't put 0 underneath. Now, irrational numbers are numbers which don't have, that are not able to be represented as fractions. Now, the thing about fractions is there's certain decimals that recur. So 4, 4, 4, 4, 4, we'll put a dot above the 4, that means it recurs. You can represent any recurring fraction, any recurring decimal, as a fraction of integers. So this is rational. Rational, 0.44444. Anything that stops or terminates, like 0.43, 12, and it stops, well, that is the number 4,312 over 10,000, and there you have an integer divided by an integer. Rational if it stops, rational if it repeats. But if it does not repeat and does not stop, okay, does not repeat, does not stop, I will use the word terminates, does not terminate, point 3, 5, 1, 7, 8, 9, and so on, with no pattern and no terminating. It is irrational. Sometimes we're not really sure if it will be rational, because maybe it'll suddenly start repeating after 10 decimal places, and that's fine. So if you're not sure, you can say not sure. There's other values. Pi is 3.141927, etc., 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 etc. So we can't write pi exactly. This is approximately, but this is, when you put the pi symbol, that's exact. That's pi exact. Any square root that will not work, that's irrational. So the square root of 15, negative the square root of 15. Yeah, you just can't have negative under the square root sign. That's not real, okay? You can't have a negative under the square root sign. We call them complex numbers, unreal numbers, but they're not real. Well, I hope this has helped, because sometimes you have a list and you have to give a list of which numbers are, say, rational. And so rational numbers can be a big list. You know, rational numbers can be -3. That's rational, because you can have -3/1. 8, that's rational. Square root of 36, that's rational. Square root of 100, that's rational. Some really tricky ones are the square root of 1.21. Have a look at that. That's 11/10. So there are some really tricky rational numbers. The square root of 1.44. You see 144, it has to have an even number of decimal places for this to work over here. Otherwise, 14.4, you've still got 144, but that's an odd number of decimal places. So that will belong in the irrationals. 0, -1/3, -4/5, 7/8. Any fractions of integers are rational numbers. And remember, if you add the set of rational numbers with the set of irrational numbers, if you add that set with that set, then you get the real number set. Real numbers equals the rationals plus the irrationals. All right, I hope this little segment has helped you know a little bit more about which numbers are rational and which numbers are irrational. Remember this, irrational decimals which do not repeat or do not terminate are irrational. But if they do repeat and if they do terminate, they are rational. Okay, until I talk to you again, stay happy.